How are you?
Hello, everybody, and thank you for joining. Good morning and good evening or good afternoon, depending on where you are. Thank you for participating in today's Neo4j live stream, Going Meta. I already celebrated episode 10, but apparently episode 12 is the one to celebrate.
Well, I mean, we can celebrate every single one because they're
We
all
can, of
special.
course,
But
we
I
can.
think, I think
Yeah.
a proper anniversary. It should be 1 year, and we're getting there. We're getting there. But it's I know we're all so excited about it that we
Yeah.
can't wait to see it happen, right?
Yeah.
But yeah,
Yeah.
it's only 10, which is
It's
still a
yeah.
still a
It's
milestone, right?
it's a milestone, exactly two digits. That's a good amount of episodes for sure. And yeah, you're right. I mean, episode 12 will be in January, if I'm not mistaken. So yeah, full year on of going meta. So I think we will have maybe we
That's
can do
right.
something in episode 12.
Yeah, we should have a guest or something. We
Maybe
have to think
exactly.
about
Yeah.
something special. Yeah.
Yeah. Yeah. Thank you, Martin. Martin just said on YouTube and chat, been loving this series, so that's great to hear. Thank you for joining, and thank you for your continuous support for this series, and for participating, and for your comments, for your feedback, online or offline. I think we talked about this a little bit over summer when we said we were, people talk
Absolutely.
to, especially obviously to you, Jesus, and tell you, hey, this is cool, and I enjoy watching this. So I mean, this is very,
Absolutely.
very
That's
helpful,
that's
and
really keeps
yeah.
us going, right? I mean, seeing that people are enjoying it and hopefully getting value out of it, because I think from the very beginning we were looking with addressing, talking to people who are practitioners, right? So we're hopefully giving tips and ideas and probably inspiration to solve certain types of problems that might be not always covered by the abundance of content that Neo4j generates, but this particular area around semantics and integrations with the semantic stack. So yeah,
It's cool. So before we dive in, I guess I'll have to say a few words about nodes.
of course.
So I'll be brief. I mean, the banner said it already before, and it's happening. So 16th and 17th of November is when it's taking place, and we'll be live streaming this one. So this is a different format, a little bit from previous episodes. So if you joined the notes before, it will definitely be a little bit different this year round. So we will be live wherever you're based. So no matter if you're living in Australia, in India, in France, in the United States, Brazil, or in Japan, we or anywhere in between, we have a piece of content schedule that is during your daytime. So we have 3 segments across the time zone. So it will work for everybody, and that makes it hopefully more approachable, more better timed for everybody to join live, to have conversations and chat, but also with the speakers, and then with the other participants. So that's the big draw. The other one is roughly 70% of all the talks are from the community members. So that means you will hear from other people using Neo4j, not only from Neo4j employees who will be there as well, but there will be other people around the community, the actual users, actual real life stories around what they are doing with Neo4j and graph databases. So I think that's going to be pretty much unique, and that's going to be a good event, much fun. So really, if you are interested in participating and watching some of this content, please register. We'd like to have you. See you there. So yes, that's notes. But today, we talk about episode 10. So, the topic today is something with SPARQL, SPARQL-based integrations and managing graph expectations.
We have to share how how much of a pain I am with the titles. And Alex is from days and days in advance asking what are you going to be talking about, and it's always last minute, and so it's entirely not his fault. It's totally mine. So yeah, that I and just a bit of context to the title, because a couple of sessions ago, we looked at RDF-based integrations. RDF, SPARQL in the end, they go hand in hand, right? So, but we covered and we kind of gave an overview of the different ways in which RDF data is available. I mean, sometimes it's available as big exports, big data sets that are made available, that are made public. Sometimes we have files, sometimes it's embedded inside web pages, which was the example that we covered in that particular case. But sometimes we have data stored in a triple store, and normally the interface that's offered is a SPARQL endpoint, SPARQL query endpoint. And we just briefly mentioned it. So I wanted today to dive a bit deeper, do pretty much what we did with the kind of embedded. We show how to extract it from the pages in episode 8 and load it into Neo. Today we're going to do something similar when we want to do something more advanced and richer and querying a public data set using SPARQL. So that's the I mean, in the end is again can be considered like a part 2 of that RDF-based integrations, but we're going to be focusing on SPARQL-based ones. And if we have time, and that's the kind, it's not a subtitle, but it's the kind of continuation to the title, which is something like managing graph expectations. So when you import data from a public data set, which is what we're going to be trying today, sometimes you find surprises, right? Sometimes data is incomplete. Sometimes data is not as you expect. And you want to put mechanisms in place to at least be aware of that and know how to react to it or how to how to inform, if you want, the downstream consumers of your graph. And that's the idea. That's what I mean by managing graph expectations. And I'll explain the whole name and how everything comes together. So that's the idea and the context for today. And again, sorry one more time.
No, that's okay. I mean, we get there every time. So I mean, that's the main point. I obviously I don't know too much what's going to happen going down, but I read a job outline today for a master's thesis, and they were talking about knowledge graph and all of that good stuff. And I was wondering, okay, this sounds very very much like a graph database questions. But then reading down, they say, okay, it's all about SPARQL endpoints and content delivery in as with metadata and all that. So it's Wikidata. So something we talked about before,
right.
But they talked about not about using graph databases, but about other things. So I guess this is a great example of how you could connect these two. Where is an overlap? Is there a reason? I mean, there's obviously a good reason for using this versus using a graph database, or is there a good way of combining the two systems for a better
Exactly.
outcome? So I guess I don't know if this is part of what we're talking about today. It sounds a little bit like it. So
absolutely, I think that's spot on. So that's the plan for today. So I think if that is okay, I'm going to, as we do, I'm going to share my screen.
Yeah.
If I manage to get this out of the way, I'll present shared screen, and I hope I'll pick the right one. So let me know when it's in front of you.
It's there. I don't know if it's the right one.
Well, it should be, the main, the slide
good.
with the title.
Yeah, I see the slide with the title.
Okay, so perfect. So I'll probably go on, I think I have everything I need here today. So I'll go on full screen for the first couple of slides. As usual, I'll give a bit of context.
Yep.
And then we'll go straight into our hands-on part as usual. Right, well, that's the title, as we've just briefly covered. And like I mentioned, today we're focusing on how to get data out of triple stores using SPARQL, and how to bring it into Neo4j to enrich your knowledge graph, right? So it's important to understand, and this is not going to be a proper SPARQL training of any kind, of course. But if you have an idea, if you're an expert in SPARQL, you know this. But if not, it might give you an idea of the kind of the options that are there. And SPARQL queries come in three flavors, right? Or three types of queries. There's a SPARQL describe, where all you pass to that query is a URI of a resource, and that resource is dereferenced or is analyzed by the query engine, and all you get is every single triple that has this resource as subject or as object, or in other words, all the statements, all the data that we have about that particular resource. It's like something like, tell me everything about this thing, and you just identify it with the URI. These type of queries return a sequence of RDF triples, as we've seen many times, and that's what I show in the column, in the second column. That is graph data, RDF triples linked together and form a graph. So that's what I mean by graph or data shape. And finally, when you have RDF data, if you want to ingest it into Neo4j, we have the option of using the Neo-semantics plugin. Right? Now, there's another type of queries, which are probably the most frequent ones, which are SPARQL select. We're going to see those. So this is kind of a high-level overview before we dive in. But select queries, even though they explore and query the graph using triple patterns, they return a table, a tabular structure. So it's pretty much like a match query in Cypher that returns property values instead of returning nodes. So you can select, okay, give me the value of that property and these other property and these other property. And what you get is a tabular structure, something similar to a CSV file. So the same happens with SPARQL select queries. And these tables, as we know in Neo4j, they're pretty straightforward to ingest. We have many mechanisms. The most popular is load CSV. So you would treat it pretty much like any other CSV file, but there are also procedures in APOC. And finally, there's another type of query, a SPARQL query, which is SPARQL construct, where that type of query returns, again, RDF. It returns triples. And when it returns triples, that means it returns graph data. And therefore, we ingest it, or we process it also with the Neo-semantics plugin. Right, so it's important to understand these three types, and we're going to look at them in 1 minute. Actually, we might look at them right now. So let's look at a very simple example. And because today we're going to be using dbpedia, this is the SPARQL endpoint. I'm going to make it a bit bigger so that it's readable. Hope that's okay. So if you go to dbpedia.org/SPARQL, right, you can run SPARQL queries there. And if you go to our repository, they're already there. We can take one example for today's session 10. I've been disciplined today, and I put it early. So we have a simple simple query here. I'm going just to copy it, and I'll comment it once we come here. So let's look at what this does, because it's very much aligned with what we're going to be testing today. So it's a select query, right? That's I believe the second type that we looked at. This is just a comment, so I'll ignore that. But basically, we're looking for something that is of type company, right? I'm looking for a company that I identify with the ticker symbol. That's the stock ticker, right? That's the identifier of that company, which is Facebook, FB in this case. And I want to retrieve the name of that company, right? And because data in these datasets is multilingual and it's tagged, annotated with the language, I want to get, of all the descriptions of all the names of that thing, I want to get the one in English. So if I run that query, because it's of type select, and I'm doing some aliasing on the projection part, what I'm going to get is a tabular structure, right? And by default, it will format it nicely as HTML, but we can return it as a CSV. But if I run this query, it's going to return the URI of the resource describing Facebook and the actual name, which is the formal name of Facebook, which is Meta Platforms, right? So no connection with our series, by the way. I mean, it's just they copied us in that name.
Yeah.
Divergence. Yeah. But you see the idea, right? So because we are in the select part of our query, we are projecting, we are selecting which actual values our query is returning. these values are basically the table headers, and what we're getting is a set of variable bindings, a set of rows, right?
Mm-hmm.
And this kind of information we're going to see in a minute that it's very easy to consume with load CSV, for example. Does that make sense? So that's the first type of query, the select query,
Yeah.
right?
Yeah.
Now,
that makes total sense. I think this is like a very standard.
So yeah, exactly. So and the other type of query, and I'm going to try, and again, my SPARQL might be a bit rusty, but I'll try it on the fly. So is a construct query. And with construct, what you're doing is you're building a graph, right? So what you're going to do is you're going to say which triples do you want your query to return. If I'm not mistaken, I have to put that between curly brackets, and I'm going to return exactly this graph, right? So if I take this, I want to return except that, because that I know what it is, because it's, I want to return this in the form of a graph. So if I execute that and I put it, for example, in one of the multiple serializations, we can use, for example, n triples. Maybe I made a mistake, hopefully not. There you go. So we get two triples. So we get the same information that we got before, roughly. So it was the URI of the company and the name, but now we get it as a graph. We get it as a sequence of triples, right? So we know that there's something identified by this URI that has a label that has the value meta platform, and it also has type. Is what we in Neo4j call a label, to make things a bit confusing, of type company. So that's we see that this returns a series of triples, right? So that's what we were seeing in this diagram. So select queries return a table, construct queries return a graph in the form of a sequence of triples. Does that make sense?
Does make sense. I think it's what usually is the complicated thing is, for at least for us, but maybe not for the viewers per se, is when you think of a graph and you turns a graph, then you think, okay, where are the nodes and edges? But in this case,
Correct.
they are there sort of, but it's not visualized in a way. It's
exactly.
It's basically two lines of it still kind of looks like a table if you
that's
but you have to think about the differences here.
Yeah, exactly. And it's a kind of a text-based realization of a graph. Yeah, it's not very
exactly.
visual, because RDF is it's a model for data exchange ultimately. So it's a way of serializing and exchanging data, right? So it's true that this pair of triples, if we visualize them, they would form actually connections. But in this, we haven't seen it really here. But the important thing is to understand the basically the shape of the data.
Exactly. And that is pretty clear.
Yeah. So the idea today, as I was saying, is okay. I have my probably a knowledge graph in Neo4j that I want to enrich by bringing in data from dbpedia in this case, and I want to ingest it. And in order to be able to ingest it, I need to understand what the shape of the data is and how to get it. And we're going to be using basically these. I will not cover describe today. We can maybe do it another time. But today we're going to be using select and construct type of queries. So how do I integrate that with my graph workloads, Neo4j workloads, which are normally written in Cypher? So I've come up with this, might be a bit horrible, but we'll go a little bit into it. But essentially what's happening is, if you look at the bottom part, that's a normal Cypher query, right? So we're looking at organizations in this case, and we're calling load CSV on something that's returned by a particular URI. So, but that doesn't really matter. We'll get into the details in a minute. But essentially what I'm going to do in all of my queries and all my integrations is I'm going to define two variables. And that's what I do with the width, right? At the header, at the top of my query. I'll define the endpoint, right? Which is the URI, the URL, where I'm going to send my request. Basically, it's the SPARQL endpoint. In this case, this is the dbpedia. So I put it in a variable. And I put in another variable that I call query or SPARQL or whatever I want. I put the actual SPARQL query that I'm going to be running, right? Something like literally copying and pasting the fragment that I've just shown in the SPARQL endpoint. That's what I'm going to put in a variable, in a text. And then I'm going to use that. And I will use it in my load CSV, or I'll use it in my neo-semantics import, and so on and so forth. But the idea is that I take these two elements, I put them in a variable, and I then can use them freely in my Cypher. So that's the idea. I hope that makes sense. And if it does, even if it doesn't, I'll go into my sandbox and try to explain it. Hopefully a bit clearer with real.
I hope it does. It
story.
does to me, but people watching, chat is
Perfect.
open, obviously, as usual. So if
Yep.
if anybody has any comments, any questions, anything, then
Absolutely.
go ahead.
Absolutely. So this is as usual, my sandbox. I think it's expiring in like an hour, so I hope it will last for this session. I mean, it's just perfect timing. But I have an empty sandbox, right? So it's as you know, it comes pre-installed with a number of plugins with APOC, GDS, and neo-semantics. So it's all prepared for us to run these these experiments. So the way I want to show it, I'm going to try to do the whole story. Like, okay, let's say, for example, that we have some data in our graph, right? And we want to enrich it with data coming from dbpedia in this case. So what I'm going to do is I'm going to seed my graph. At the moment is empty, so no nodes there. So what I'm going to do is I'm going to create just some dummy nodes that represent organizations. Why am I doing that? Well, what I try to simulate is I'm not starting from scratch. You probably have a graph that exists already. Maybe you have data that you have added to the graph. You have some data that you have imported, whatever. So you have in this case a number of organizations, and you're going to want to enrich that graph with this external data. So, like I say, I'm creating a bunch of how many 8, 9 nodes here that just represent an organization. Let's assume that it's part of the information in my graph, and effectively all I have is the ticker. It's like I need some kind of hook that I'm going to use to go and search the extra data from the triple store. And in this case, I'm going to use that. So at the moment, like I said, we only have a bunch of nodes representing organizations that I will want to enrich with data coming from an external source. And all they have is this ticker ID, right? You see Facebook here, Caterpillar, Duolingo, and some other organizations, right? So that's our starting point. Now, for each one of those, I'm going to want to do this, right? If we go back to our previous query, and let me revert it to the original select mode that we had at the beginning. So what I want to do is, okay, I'm going to pass you the ticker, the information. It could be anything, right? Think of your graph. You might have the URI, you might have the name, you might have some kind of ID. In this case, we're going to use this because I find it, simple enough for this session. But I'm going to pass you an ID of my company, and my query is going to return me 2 things. Oh, I don't want this. I want to put it back to CSV. So let's put it in HTML, which is nicer here. So I want my query to return me 2 things. For example, the URI and the name. So let's say, quite simply, I want to, for each one of my nodes, I want to go to dbpedia and retrieve the name of the company. And then I'll see what I'll do with it. So in other words, what I'm going to do is take this query, right? And I'm going to put it on a Cypher query, pretty much like I described in the slide before. I'm going to do copy, paste, and comment rather than trying to make a mistake. I'm quite keen on live coding, but sometimes in these cases it's safer to do it like that. What am I doing here?
We can explain rather than write the code. Yeah.
I hope it's real. I'll make it a bit bigger.
No,
But that's the structure.
Do you mind clicking on hide on the bottom of your screen on this little sharing?
Perfect. Sorry.
Thing.
Brilliant.
Thank you.
So yeah, you see the elements that I described before. So at the top, I'm defining my endpoint, which is exactly what I'm going to be sending my SPARQL queries, which is no other than this one. As you can see, it's pretty much, here I'm doing it manually, but here I'm going to do it programmatically. And all I have to do is pass the format that I want in return. In this case, is CSV. And I pass as a parameter the query. Now the query is going to be my second variable. So this is my Cypher query, my SPARQL query, exactly the one I've just run before, with a simple change. And I put it on a query variable here. What's the change? Well, instead of running it systematically for Facebook, I'm going to pass a variable that's ticker. I mean, we can do it in different ways. I mean, what I do is I put an indicator that's, for me to understand that this fragment has to be replaced with the actual ticker, with Facebook, FB, or Snowflake, Snow, or whatever. So that's my way of doing it, but we could have the prefix and postfix and just embed the value. We can do it in many different ways, but that's simple enough. So once I've defined these two variables, my query or the template of my query with this element inside, and my endpoint, where I'm going to be sending my requests, the rest is just Cypher. So look what I'm doing here. So I'm matching my organizations where ticker is not all, just a safety measure to make sure that they all have this ticker. And these will find, as you can imagine, these organizations here, right? That's a simple query that will return all these organizations. And for each one of them, the actual ticker, right? So I match the organizations. And for each one of them, I'm starting a load CSV request, right? And I'm saying that instead of putting the from statically, I generate it dynamically. And how do I build it? Let's put it in another line to make it probably more readable, but it's just the concatenation of the endpoint. So I'm putting my URL, or that's where I have to send this request. And then that should be followed by the actual query, as you can see, which is this fragment here. So that's my query. But what I do is, okay, go and replace this ticker element, right? This kind of macro there that I put with the actual ticker that comes from my organization node. Does that make sense? Actually, to make it simpler, here's what I'm doing. So let me, before I run this, I'm going to return it. So this is what I'm going to be doing. That's my request. So it's not going to look very nice. Well, why did I make a mistake? Load C. I don't want to put the load CSV, of course. I just want to return that. So it's generating for each of the nodes that are found, for each of the organization, it's generating a request, right? And concatenating the actual query, but replacing the ticker of the organization. You see CAT, ACN, FTNT, Workday, Snowflake. So it's just a simple replace. That's what it's doing. And now each one of these requests is actually, if we wanted to run it, we could. It would download a CSV because they're valid. They're well-formed requests, right? So that's exactly what I was doing. So, but instead of returning it, of course, what I want to do is do a load CSV from this endpoint, right? And I want to return this as a request. We just want to put it there as row. And we can, for example, return results. So we can return what we can say, okay, the ticker. And we can return also, we know that the rows that this query is going to return look pretty much like that, right? So it's going to have a URI column and a company name column. So I can return row.uri and row.company name. So if I run this query, I've made a mistake, of course. I told you that shouldn't be good. Why did it not like it? List string. Okay, so let's actually indicate that it's with headers, because that's how it goes. And now it should look nicer. And for basically for every single node in my organizations, it's sending a request to SPARQL endpoint, and it's returning the two values, the URI and the company name, right? So that's what we're doing. At the moment, I'm not doing anything with it. I'm just showing it on the screen. Yeah. But I could do whatever I want, right? Yeah. I could now, because now we're in Cypher territory, I could say, well, instead of returning it, I could go and why not? I could say, well, take my organization and set the value, for example, company name. I could do that. Something like row dot, we called it, was it company name?
This was company name, yeah.
But if I do that, instead of returning it, it will be updating my nodes. So, but yeah, you see that, and it's set 8 properties, and now my nodes will have not just as we had before the tickers, but we'll also have a company name, right? So we see that they've been enriched with the company name. So there you go.
Cool.
So that's my first basic example. Okay. So we can, I mean, if we think what's happened here, so we had a graph, and we've decided to enrich a portion of the nodes in my graph by issuing individual requests to a Cypher, sorry, to a SPARQL endpoint, and retrieving, in this case, a value, and persisting it as a property. For this, we didn't need anything special. As you can see, I've just used load CSV. We can reanalyze the query that we've run, but there was, I mean, even if there was interaction with an RDF store, it was all table-based. No need, in this case, for example, for neo-semantics or anything similar, because there was no RDF change. It was just CSV returned by the query. Make sense? Perfect. So let's now look at a richer example, right? What I'm going to do is I'm going to delete everything. And I'm going to start from scratch. Yeah, okay. So I mean, it's going to be exactly the same, but now I'm going to do the SPARQL. I'm going to recreate my seed organizations. And now what I'm going to do, instead of using a select query, what I'm going to do is use a construct query, a query that returns RDF. But then when I ingest RDF, I'm going to have to process it with neo-semantics, because there's no direct. I mean, we could, but no simple way of ingesting RDF directly from into Neo4j. So we're back to our starting point where we have our organizations with just the simple ticker. That's all we have. And now, one question, because I got that asked sometimes. So when you go and get data from an external source like dbpedia or Wikidata that we've used in the past, if I have a node in my graph that's already connected to other entities, what do I do? Do I use that node and enrich it with data like external data like we've done? Or do I create like a twin that represents the dbpedia version of my node, and I keep that additional data in a separate node? Well, it's entirely up to you. So we can actually play with this idea. So we can say, for example, let's take the same query that we ran before. So if we have the same approach that we had before, I'm going to do, instead of setting a property in my node, what I'm going to do is I'm going to create, let's say, a twin of my, actually, before I do this, let me do that. Because as you know, when we're going to, and otherwise it's going to happen in a minute, and I don't want it to interrupt me. But when we are about to import RDF data, there's a couple of configuration things that we need to do for neo-semantics to work. I'm going to get it out of the way. You know that I like to do it, in a lazy mode, just get the error thrown and then create it. But this is what it's just I'm creating an index to identify RDF data as resources in Neo4j and index them. And the second one is just creating a configuration, right? I will not go into the details. We've talked many times about that, but it's basically saying, how should I treat the RDF data? And that's what I'm doing with this. Okay, I need a semicolon to have the two run in the same step. Perfect. So now that's done and out of the way. And I was saying that if we want to ingest data, we can do in two ways. We can use the nodes that we have and enrich them with data coming from outside, or we can create like a twin of our node, and that would be very simple to do, right? So we can just use the same query that we had before, and we could do it in this way. For example, let me again copy paste. So for it's important to understand that when we import RDF data into Neo4j, the way for neo-semantics to identify things, to identify RDF resources, is to tag them, to label them in Neo4j as resources, right? And give them a URI, which is the unique way of identifying things in the RDF world. So one thing that I could do is, okay, I can just with the same query that we used before, I can say, I'm going to tag my my organization nodes as, I think I've copied it. Let's paste it. So no, that's not what I wanted to add. What I wanted to add is anyway, I'll code it manually. So what I'm going to do is I'm going to say, okay, my nodes are resources actually, and they have a URI that I will get from row URI. What I'm doing here is I'm saying, okay, my organizations, the nodes that I have, I'm going to also label them as resources and give them a unique URI that I'm going to get in this first iteration.
Okay.
And like this, let me run this first and hope that everything goes well. So by doing that, what I've done is kind of, I've turned them into, let's look at them again. I've turned them into kind of RDF resources as well. So they still pretty much the same information. So we have the organization with the ticker, but now we've added the URI, right? Which is key when we import RDF data to have the merging happening smoothly. And we've labeled them as resources, which is a way of saying this is an RDF resource. Now,
maybe we need to explain that in Neo4j you don't necessarily have to duplicate, because initially I thought you will clone.
Correct. Well, that's
A
right.
node and have a separate node in itself, a separate entity. But in this case, we don't necessarily have to do that, because you can assign more than one label to a node. And with
That's
that, you
right.
have sort of multi labels, and with the multi labels, you can say, okay, this node is like we shown here, like it's an organization as well as a resource, and they have different properties depending on which label you're looking at. So you don't have to clone it all, and you don't have to do two separate nodes with the same, well, different labels but same properties, or different property sets but the same. They would align to the same node in itself, but here we just added another label.
Yeah. Now that said, and you're absolutely right, and I went with this approach because it's the way I would do it. Sometimes people might want to kind of isolate the two bits of information, the two groups of two information sets, if you want. So there's facts that I have about Facebook in my knowledge graph, right? And maybe they're tracking news or they're looking at any other metric in your graph. And they want to enrich it with all the information that we're going to get from dbpedia, but they, instead of mixing it here, they want to be able to know, hey, but that's data that comes from dbpedia, and I want to keep it in a separate node, even though it can be done, and that's probably the simplest and the more compact way of doing it. I'm not saying, it's something that you would never want to do. Maybe in some cases you want to say, hey, and that's my dbpedia twin, and that's where I keep the information that I get from dbpedia, and I don't want it to be mixed, because we're going to say that the data quality is a concern, and you might want to keep it separated. So agree with you, and that's what the solution we're going with. But in some cases, and that's why I wanted to mention it, people might want to keep it like separate for that reason.
Yeah, and it makes total sense. If you have your internal data and your internal knowledge, and you want to make sure that this is not somewhat confused with external data that comes from somewhere else, you might want to split it really apart and say, okay, for query reasons, we're going to look across the two, basically two graphs that you were creating by doing that. And for some other reasons, you think, okay, it doesn't have to be like completely split. It's fine if we have it here underneath one, visually represented as one node.
Exactly. So what I'm going to do now is, I'm going to show a more advanced query, SPARQL query. And I mean, we can have a look at it actually here. It's nicer for readability.
Good comment, by the way, on this, what we just said from Juan on the chat. You could also add a prefix to the properties.
Absolutely.
And so you could even, hey, okay, let's keep the node. Let's have it with one label, but say dbpedia dot name is string, and then okay, these properties come from outside, these come from inside your there's a couple of ways you can do it, depending on how split it very far and be sure that this is no confusion, or combine it in one and have it very close. Depends on
Yeah.
what
So
you want to
you
do.
define, you define your requirements in terms of provenance and being able to isolate and determine where data comes from, and or data quality levels, and I'm giving you the options here, but like you see, I mean, once you get the data in Cypher land, in Cypher world, you're free to put it, like we've said, separate nodes, even tagging the labels. The options are endless. It really, and we've seen many different approaches for these problems. So yeah, I agree. And I was saying that, what I want to do now is, okay, because I can, I mean, I could go and extend my query here, but think of it. I mean, here I know what I'm after. I want to get the URI and the name, and I have two headers returning precisely that. Now, I want to write a query that returns anything that dbpedia knows about Meta, about Facebook, right?
A company.
And I don't want to have to write a query that with 75 columns and then having to take the columns and manipulate them. I'm going to say, okay, give me everything, and I will, in the form of RDF, and I have semantics ingesting it smoothly and producing a graph, because that's what it is. And that's exactly what I want to do. And I'm going to run this query. I say it's simple, but look at the query. I mean, it's not like, what I'm doing is very simple, but it's unfortunately a bit verbose, and also I have to say that dbpedia is a tricky data set. I mean, it's not the easiest to work with, and I'll show an example in a minute. Because what I'm doing here, again, if you look at it, is it readable, or shall I make it a bit bigger?
Maybe a little bit bigger, or
There you go.
Yeah, I
So
think that's good.
hopefully that's better.
Yeah,
but
that's good.
First of all, is a construct query, so it's going to return some triples. But if we start from here, I mean, we start pretty much in the same way. So I'm passing the ticker, and that will help me finding a company by the fact that it's a company, and the ticker, which is a unique identifier. So once I have my company, the resource representing that company, I'm going to get, and this is a completely generic pattern, a company, any predicate, and any object, except that I'm filtering it further down. And the reason for that is, like I said, there's a lot of noise in dbpedia, and I want to make sure that I only get data that I'm interested in. So what I'm doing is a number of things, like, okay, I want to get all the objects that are literal, all the data type properties, but I want only those in English, right? Or those that are not tagged, but basically I want the English version of it. I don't want all the multiple languages, not for these ingest. Maybe in some other cases it might make sense. And also I want to restrict the predicates. I don't want everything about Facebook, and we're going to see in a minute why. I want just the things that are part of the dbpedia ontology, and excluding what else? No, that's pretty much it. So that, and including the labels, but just the predicates in the dbpedia ontology. And the reason why I do that is just to exclude some noise, because there's loads and loads we're going to see of all the statements that use different vocabularies and that can pollute a little bit my graph. So I'm restricting it to that. And then optionally, I'm going to retrieve other entities connected to my company in dbpedia. And I want to get people. So I want to see when my company connects to a person, and I'm indicating that is a person down here because it's of type person. And I'm filtering again. I'm just getting the predicates that are in the dbpedia ontology, and I'm skipping the ones that are Wikidata links. I believe a good part of dbpedia is the result of processing the boxes in Wikipedia, and some of them are just that Wikipedia links without any context or any meaning. So I want to exclude those, because to me they're not very useful. So that's another way of filtering, and I do it on outgoing and incoming relationships. So here the company is the subject and the person is the object. Here is the other way around. So this is all very verbose, I have to say. I mean, in Cypher it would look very different, but that's what I have to do to get, I mean, and of course suggestions are welcome, but I essentially want to write as simple as possible SPARQL query. What I get for a given company that I identify with a ticker, connections to people, to entities of type person, and connections to things of type place, of type location basically, and all these filters are just data quality ones, right? So yeah, sorry, it has to be that complex, but that's what it is, right? So
Yeah.
good. So this is the
Well,
query that I'm going to.
that's like what Martin also said. This only in the ontology filter. I think that's a very powerful movement, because when you say you have lots of noise and lots of
Exactly.
things going on, you end up with, of course, you import everything, but do you really want to import it all? Is it helpful for
Correct.
you to have lots of not relevant or not really interesting stuff in your notes? And in the end, so if you can filter out some stuff where you know right away, okay, this is not helpful or not needed, then doing
Exactly.
it here and making it, making that first loop a little bit more complicated, but afterwards having the result of cleaner data you can then work with is
Yeah.
probably worth the effort.
And that's a very good point, because we could take two approaches. I mean, we could. We in this case, I've written more complex SPARQL to take care of this filtering. I could have written simpler SPARQL in just a lot more triples and then filter on the Neo4j side. So it's a question of whether you feel more comfortable. I mean, are you okay? And that's a question for each developer, right? You want to write these expressions in SPARQL, or you want to say, give me everything about Facebook and I'll filter it out on some post-processing in Python, for example. Well, maybe that would be another option. But in this case, we've gone with
So
this
many
one.
options.
And if I run this query, we'll see, because it's a construct one, it's going to return a bunch of triples, right? So just to show what it returns, basically it's a sequence of triples. That's the case for Facebook. And some of them will be literal properties, like the net income, as you can see. For example, the name, you can see Mark Zuckerberg there, and so on and so forth. The wiki page length, very interesting data. Anyways, this kind of thing is what we're going to be getting. So that's after the filtering, right? So this is the RDF that my query generates. And now I'm going to show how I'm going to actually, it's pretty much the same pattern. It's just a bit longer, as you're going to see. But let me copy that code and go to my browser and hope it's readable. But same pattern, right? So we start with the width. We've put the big fat SPARQL here, right? It's just there. All I've done, just like I did before, is I replace the ticker with my template so that I can replace it for every single organization and not just for Facebook. Then I have my endpoint, pretty much the same, right? So to have the variable there, endpoint and SPARQL. And with these two things, I'm going to proceed exactly in the same way as I did before. So I'm saying, okay, go find my organizations where they have a ticker, because if I don't have a ticker, I cannot run this query, because that's the way I built it. Now, the difference is, instead of running a load CSV like I did before, because my query was returning tabular data, now my query is returning RDF. So my way of importing RDF is running Semantics and 10s RDF import. So that's what I'm doing. So I built the URI exactly in the same way. Endpoint, which is this URI, concatenated with the replacement of the ticker in the template there, and that's pretty much it, right? And now,
so maybe for people not so familiar, so APOC is a specific set of extensions for Cypher. Awesome procedures on Cypher is what it is, and this gives some additional features or some additional functionality that Cypher would not have out of the box. And here in this case, what we are doing is, obviously the endpoint is a URL as shown in the top, but then it would not go anywhere, because we have a variable, we have the individual company names, and we need to add a few bits and pieces to that URL. So that is what is done here with this text URL encode, which makes the additional
exactly
the rest, basically the bit needed after the equal signs and the plain and query at the endpoint.
Exactly. So the replacement and then the encoding to make it valid for the URL. So this is going to be pretty much like before. It's going to be generating one HTTP request to the dbpedia SPARQL endpoint per organization that we find here in our match section. And when that runs, that will return RDF that will be imported directly by Semantics into Neo4j. And we will return a summary of the execution of that import. So if there's been no mistake there, hopefully you can run that. And if everything goes well, it shouldn't take very long because it's just 8 organizations. There we go. So we get a summary. It terminated OK for each of the tickers, and it tells us how many triples were imported, and that's pretty much it. So now let's explore what we have. And remember, we had organizations before, right? And we still have them. Now, the thing is, if we go to any of them, if I click on Facebook, now it's a much richer structure. You can see that we have an abstract, we have assets, we have former name, we have founding date, and so on and so forth. So a lot of properties have been imported from this process, and also relationships have been created. So Facebook is connected to a bunch of additional entities that have been also ingested as a result of this process. And Mark Zuckerberg
definitely didn't have those before,
among others. Absolutely, we only had the notes, and that's just like I said before. I've restricted it to entities of type person and of type place. So we have that Facebook is connected to this place, which is where the location, city, predicate. But all these, I didn't specify what I said. Give me any relationships that you find in dbpedia and bring it in. And I'm going to show, because of course, what we did at the beginning is give our nodes a URI, right? Which should be here. Here we go. And this is clickable. So I can go to that URI, and we'll see a human readable version of the information. So that's all the information that dbpedia holds about Facebook, right? And there's plenty and plenty of properties. So I didn't want to bring it all in. And that's where I've filtered just the things that have this DBO prefix. So things that are in the dbpedia ontology, right? So that's what I've done, because and even there I've restricted some of them. So for example, the Wikipedia links, I've removed them. So maybe in the wiki page for Facebook, there's links to AT&T, to Morgan Stanley, but it's just that. I mean, it's a link with no semantics. It's a wiki page link. I don't know what that means, why it's there, because it's not part of the information in dbpedia. So that's why I wanted to exclude those, because otherwise it would be too much noise, and many others. For example, I don't know. I will not go another templates here. Geospatial point. I don't know what that would mean. Same as a type of statement. So lots of information that I'm excluding, because I wanted to keep my graph tidy in this case. Let's take a quick pause there, because I would like, well, and the same has happened hopefully for all the others. If I take this other organization, it's a bit less rich, but we see that we have added all the properties, and the same for the rest, right? So here we go. Let's take a break here. So because we've got to the we have 5 more minutes. I'm not sure we're going to get much further than this. But well, I hope at least, if I get back to this, we've seen these two patterns, right? The select and construct. So we've seen how one returns tabular data and the other one returns graph data in the form of RDF. And based on that, we can either, like we've done, dynamically import data based on content in our Neo4j graph, like we've done. For every organization, send a request, return, and enrich. Or you can basically take control and do whatever you want. Right. Any questions? Does that make sense?
Yeah.
Because I think what I'm going to do is, because we don't have time, I'm going to just introduce what I was planning to show in terms of managing the graph expectations, right? Because as I mentioned before, when we ingest data from, let me show you one example that that struck, I found interesting. So one, if I keep expanding here, we should hopefully find something that I found interesting. Here we go. That's it. Where is it? No, that's not what I wanted. Let me try to find a person. Okay, here we are. That's it. So I look for persons in my graph, and suddenly I find United States, and I say, hey, that doesn't sound like a person, right? So, and interestingly, where does that come from? Where when I enriched the data about Workday, right, which was one of the organizations that I had, and you see that it has a location in Pleasanton in California, and two individuals are, let me make it bigger, so connected to the organization. It seems to be connected to another organization that is, interestingly, both a place and a person. And I wouldn't expect that, really. But it's actually what it is, right? So if I click on United States and I go to dbpedia, it might take a bit, but we'll see that effectively that's, if I look at the types. So if I look at the types, interestingly, it's a person and a place. So why? I have no idea, but I this kind of noise or this kind, I mean, maybe there's a reason. I don't want to judge that because I don't know, but it's a bit unusual, right? To find that something is a location, a place, and also a person, right? So because it's there and it's in the dbpedia ontology, and it's stating that this United States entity is both a person and a place, well, Neo4j imported it, and now we have United States being both a person and a place. So I want to be able to detect these sort of things and say, hey, there's something abnormal. Maybe you want to check it out or see why is that. So even when you take care of filtering data out like we did on SPARQL, it's inevitable that you will get some unusual or unexpected bits of information like this one. And that's what I wanted to cover. And clearly that's going to be a topic for the next session. What I wanted to define the graph expectations. And just to set the context, I mean, the name and the concept itself comes from this great, let me bring it up. It's a library. It's a Python library that does pretty much that, but in the relational world, right? So there's great expectation is the name, and they allow you to define these kind of rules. Like I expect that table or that column in the table to have values of type integer. I expect that table to have values in a range between that and that. So it's a way of controlling your data assets and making sure that any anomaly or any expectation is detected before it's used downstream in an uncontrolled way. I think that's a great concept. It's not only them, but I think the name and the way they did it is brilliant, and I totally copy their approach. So I was thinking, how can we do that with in the graph world? And because we have an element that we've talked about before, which is shackle, which is a way of defining these kind of shapes, I thought, why don't we create something like great expectations, but for graphs? And that's exactly what graph expectations is. And that's a package that we'll cover in the next session. But the idea is that I want to be able to define expectations. Like, for example, when I get a company, and this is Python code, but I guess it's understandable. I'm going to define my expectations of categories in my graph. So for companies, I expect the property values to be of a particular type. So founding date, I expect it to be a date. And if it's not a date, maybe it's rubbish data or it's something that I want to have a look at, right? I expect the number of property values for the founding date to be between 1 and 1. I only want to have one founding date for an organization.
Yeah.
I want, relationships, outgoing relationships that connect a company to a location to connect to an actual location, not to a person like we saw before. So these kind of things is what I'm going to be doing with this library, and then have it run against my graph. And but yeah, we've run out of time today, so we'll touch on that in the next session. I hope, at least up till here, we saw how we can use SPARQL to enrich the graph.
Yeah.
But we just ended up on that mysterious note that even doing that can introduce some pollution somehow in your graph, and you will want to take control of that. But that will happen in the next session. So yeah. I'll stop sharing.
I think that sounds very interesting. This great expectations, graph expectations idea. So I think that's really where you I mean, you can sense. I mean, there was another comment on chat from Juan is Shackle could be helpful for constraints. I mean, you can set some constraints in Cypher within Cypher for Neo4j as well. Some of these can be done, but if you have a tool that sound, what is it called, checks for soundness, for that it works before you actually, then I guess you would save some time or some effort, because you have some kind of, you don't have to look for it every time you do something, but you have, okay, this is like your backhand of validation, sort of. You say, okay, if it's like you just said, if it's a location, I want I don't know, a geo point or something. If it's a date, founding date, I want just one number, and this applies to every time I'm importing stuff. So every time I'm looking for it, every time this is relevant. I don't have to set the same stuff every time yet again with either constraints or some other limitations. But I know, okay, this bounces back through that list, and okay, this is what I want to get back.
Yeah, absolutely, and that's right. I agree with Juan that that's Shackle will cover a part of that, everything related to the structure of the graph. There are many more metrics that you want to control, and of course, great expectations and many other, because it's not the only one, are way further down down that line. Things like, for example, I expect to have at least a number of these type of entities. Every time you do an update. This is not something that you can express with Shackle, but it's a great starting point at least, and it presents it in a way that's more understandable than because I think I mentioned my frustration, because I think it's a super important topic, but the session on Shackle that we didn't have the same level of views, and it's probably because it's perceived as something complex, and that's probably right. And that's the reason why I created this graph expectations library, because I don't expect people to write this Shackle, because writing RDF is not nice. But if you have a library that makes it really nice and intuitive, and suddenly it generates it under the hood for you, that can go a long way. But yeah, very, very important. I mean, I've had this conversation at least twice or three times this week. I mean, and big projects. One of them, one of our teams is working with Novo Nordisk, with the pharma, the Danish pharma, and they've created this open source project called you probably can help me here. It's Study Builder.
Yes, Open Study Builder. It's what it's called. Yeah.
And they're looking. They have to do massive data refreshes, and they want to be sure that, like every other data solution, they have under control the impact of that ingest. I mean, they want to know that it went well, not just from the point of view of the program ended. I want to see if there was data of a particular type missing, if the quality went down by for whatever reason, right? Because it integrates data from multiple different sources. So this idea of being able to programmatically, in an automated fashion, applying techniques like we've used in software, like unit testing. When we every time we release Neo Semantics, we run a whole batch of unit tests, and that's all automated. So we would not release it without all these tests, but unfortunately, and that's because the data world is a bit behind. When we have a data solution, all these checks, all these automated checks, we struggle to create them, and that's one step in this direction. And that's where great expectations are great in what they do, and what I think we have to give tools to the graph people to do these sort of things. So that's where we're going. But yeah, that's probably a topic for
as in a perfect series, best practice. We end with a cliffhanger. So I mean, you watch season 10, episode 10 of season 1. If you want to, if you want to know more about graph expectations, you have to continue watching, and this is gonna be then next time around. So yeah, please like and subscribe, obviously. So I guess that's another one I have to slot in every now and then. So yeah, I think that's good. And I let's not rush it. I think this is important. This needs some time to explain it, to set up properly, and rather spend some time about this with more time in the next episode.
Great. So I don't
Yeah.
know if there's no more
That's
questions.
cool. Martin, again at work, my crew tease me asking, "Is Neo4j your new religion?" So, I mean, well, it is. It is. Once you think about it, once you think in graphs, I think it's hard to go back. At least that's what I realized and what I discovered. It's you have, once your mind is open to it and you realize what powerful tool it is, then it's going to be hard to switch to back to tables, I guess. I hope you agree, Jesus.
Yeah, no, absolutely. I mean, I think the two go. I mean,
Yeah.
tables are useful where they are, but it's
No,
good to
totally.
have
Yes, I
the
was just
two
kidding.
tools at hand. I mean, and that's another topic that I will want to explore in future sessions. I mean, there's a lot. I mean, a huge amount of people are working, with that SQL to do kind of traditional data analytics. Ingest data, aggregate, clean, and produce dashboards. I mean, that has worked very well with tables, and I want to explore how graphs fit into that type of into that space. But that's a bigger topic. So, but I agree. I mean, graphs definitely open the door for an incredible amount of new types of ways of exploiting your data and getting value out of it that you will be missing with just tables. So I think the perfect amount of both is where you want to be as a data person.
That's right. Yes, I mean, I was obviously kidding a little bit, but yeah, I mean the two combined, I think it's a very powerful feature. So yeah, I think thank you for watching. We are finished for today. So again, we will be back in a month. If you, in the meantime, please check out notes if you're interested. So that's gonna be the next big session. What's coming up this week later on? Just to briefly explore this, tomorrow another Road to Nodes workshops is taking place at 4 p.m. Central European time, and on Thursday, I'm very much looking forward to a special guest where I'll be talking about graph data, graph visualization with Kirill Benzi. You might have seen him. He's TED Talk and a very public speaker, and he shows us how beautiful graph visualizations can look like and can be like, and in the data meets art kind of space. So I think that's going to be a very cool session. That's this Thursday. So if you are interested, have a look, tune in on YouTube and Twitch and LinkedIn. And yeah, with that, I think we are good for today. Thank you, Jesus. Thank you for your work on this preparations and the demo. Thank you all for watching, and see you soon.
Yep. See you all. My pleasure.
Thank you. Bye.
Bye bye.